Why are there no new ideas in computing? By the end of this episode, I hope to explore this idea. It's something I've been thinking about a lot, that there was this kind of golden age in the 60s and 70s when a whole bunch of stuff got invented, and now we kind of took some steps back and we're still uncovering all that stuff. So what happened? My name is Eric Normand, and I help people thrive with functional programming. There's a Stack Overflow question about something that Alan Kay said, that there were no new inventions in computing since 1980. And to a lot of us, that's pretty surprising, because we work in computing and we feel like new stuff is coming out all the time. And so the person who was asking was like, what does he mean by this? And so he answered. Alan Kay answered the question himself, and he set it out as a challenge. Like, what are the things that you think are new? And a lot of question or answers came in to his challenge, and he kind of said, well, but in 1967 there was a paper where they talked about that, and maybe this is a new implementation. It has a lot of practical improvements, but it's the same idea but newer. And he just goes down the list, people coming up with ideas, and he just says, well, here's a paper, and so what's going on? Why is it that things kind of stopped and we're still trying to catch up to where people were back then? And Alan Kay has mentioned it before. I didn't really understand it. I've been thinking about it, researching it. And the best answer I can come up with, this is something I just think about all the time, is the microcomputer revolution. The commercialization of microcomputers has really set us back. Now, it set us forward because we have cheap computers now, because they became like consumer grade, and now we have, I don't know how many computers I own. I stopped counting. There's computers in so many devices now. That wasn't the case when microcomputers first came out. It's so we have all this new computing power. I can go on to Amazon and just start up computers in the cloud, as many as I can afford, and they're not expensive. And it's amazing. We have all this great power, but the systems we use, the programming languages, the operating systems, the software is all from this time. It all stems from this time when we had to rebuild everything. So imagine you were a researcher at a university, and you had maybe not a mainframe, but you had a mini computer, right? Not a microcomputer, but like a step up, order of magnitude bigger than what was available like in an Apple II, right? So it's a really powerful computer for the time. Cost thousands of dollars, like $40,000, $50,000, and those, in the dollars of the time. So pretty expensive. But you could do research on it, and you could work in an advanced language with a compiler, with a decent editor, and you then look at this microcomputer that has no compiler. The language on it is BASIC, and if you need to do anything sophisticated, you have to go down to assembly. You would just look at it and say, I can't do the algorithm research that I'm working on at work or in my job on this small computer. So, here's another way to look at it. So Steve Jobs went to Xerox PARC and saw the Smalltalk system that Alan Kay's team had developed and was blown away by it. Smalltalk was running on a $30,000 machine that took up like the whole desk and had these big tapes for storing your project on. You'd have to load in the tape. But then once it was all loaded, it was very interactive. You had a mouse and you could change the code as it's running and, move documents around and stuff like that. And it was a big inspiration for the Macintosh and, and from there Windows and, everything we use today. But what was, and so this Smalltalk system had this really advanced language, an object-oriented language in the 70s that you could click on anything, see the code for how it worked, modify it, hit save, and then the behavior of the system right there in front of your eyes, no recompilation step or anything, it would just be different. And in fact, they did this in the demo, but Steve Jobs missed it. The other programmers that were with him from Apple saw it. But anyway, what's important is that when they went back and said, we got to put this on the Macintosh, what did they develop it in? Assembly. And they made a pretty nice GUI for what could run on the hardware that they had, the, commodity consumer hardware that they were making. They wrote it in assembly. You couldn't change any code on it. It was a very kind of dumbed down system, and they had to make it fit on the hardware that they expected people to be able to afford. But it's that kind of down step that we took from this expressive, super forward-looking system, the Smalltalk system, down to a system that, yes, made it easier to use. Yes, it had a lot of nice things about it. But in terms of like a programming machine and advanced concepts like being able to modify code and understand how every piece of the system worked, it was a big down step, backward step, if you will. And then over time, the computers, the microcomputers that were commodity hardware that were produced, eventually they caught up to where the Alto was. That's what the Smalltalk system was running on. And they were much cheaper, but the programming systems did not. Right? The programming systems, maybe they're not in assembly anymore. They're in C or Objective-C or what have you. But they never took that leap and said, wait, we can run Smalltalk now. Let's start over and like reinvent what we have from that beginning, because they needed to sell every year. They were a business. They needed to commercialize this, and they didn't want to start over. People were learning the GUI. They didn't want to have to say, well, here's a new GUI that we invented for you, because people had invested in training their staff. They didn't want to have to retrain them on the new GUI. Right? So there's all this investment and sunk costs that are going into it. They couldn't change it. They can make incremental improvements, but they couldn't say, whoa, wait, let's stop, because we could do what they were doing in the 70s now on our hardware, and we would be like basically where they were with this advanced, expensive computer. We could do that on our cheap commodity computer. But no one's ever done that. And it's odd that no one's ever done it, but you can see why. It's because they're always trying to get the next release out, just adding features. They're never doing the big rewrite. Big rewrites are expensive. They're risky. Just keep coming out with the next thing. And so we find ourselves in 2019. That's when I'm recording this. I have devices here that have operating systems that, don't have some of the features that Smalltalk had back in the day. I can't click on anything and change how it works. The software we write for them in general is still like from the batch computing era, where we submit a program to a compiler, which compiles it, generates an executable, and then we have to, basically start the whole thing over. It does not provide objects that I can interact with in the same way that a Smalltalk system had, right? Any Smalltalk object would have like a methods that you could call, messages you could pass it. So just as an example, like I'm recording this on my computer here, and I've got a window open. I mean, you can't see this, but I'm going to talk about it. I've got a window open. It's the QuickTime Player. That's what it's called. It's a piece of software that records video. How do I get the frames out of this? Shouldn't there be an interface to this object on the screen that lets me query it for, a frame at a certain time? Or how do I get the raw stream of it can talk to the camera. This QuickTime Player can talk to the camera. How do I get the raw stream of frames out? It somehow knows how to do it. I want to use the encoding that the QuickTime Player knows how to use. I basically don't own this software. There's only 100 things I can do through a mouse-driven interface. I mean, yes, you can. There's keyboard shortcuts. That's not what I'm talking about. I cannot write software that interacts with this software. I can't change how this software works. And they could do that in the 70s on the Smalltalk systems. To this day, when you get Smalltalk software, they give you the source code. They give you an image that contains the whole thing. It's everything. Here's our software. And so you can you mess with it. You change it. You make it do what you want it to do. And I think it's a total shame because we get this software. I'm thinking about video editing software. Final Cut Pro. That's what I use sometimes. And I want to change it. I want to make it different, and I can't. I just have to learn how it wants me to work with video. And I want to work with it in a different way, and that doesn't count. And it's my computer. I paid for it. It's my software. I paid for it. And I can't modify it. So we took this huge step back, and a lot of ideas are now reaching the light of day. People are reading the old papers because they're on the internet now. That's a good thing. People are talking about them. There's conferences about old papers. People are implementing the ideas in their favorite programming languages. That's awesome. But I still feel like that's just piecemeal. We need a revolution. We need to start over. We need something to reset where we are, because these computers, this thing on my desk is way more powerful than an Alto from 1970. It's ridiculous. It costs way less, even accounting for inflation, especially accounting for inflation. But it's not as powerful in the sense of giving me power as a user. But of course, it's not going to happen because Final Cut Pro costs something like $300. And if they let you develop your own editing software in an easy way, meaning what if Final Cut Pro was a bunch of objects? What if it was not a full suite that has a fixed interface? What if it was a bunch of objects that you could program together? I've seen the Smalltalk demos. They were editing video then in the 70s. And it was a simple interface. They're like, oh, let me throw something together to help me make this video I just recorded. They threw it together. That's what I want to be able to do. Well, this is turning into a really downer episode. And I don't want to end on a negative note. I think we are coming, the industry is growing, but it started growing so fast when those microcomputers came out. It's been doubling very quickly. And the number of researchers, there were COBOL programmers back then when, working on mainframes and stuff. Those are run-of-the-mill, code monkeys. I have to say it. They're just people getting a job done, doing, making some banking software, getting the business automated, whatever they're doing. They're not computer researchers. They're engineers. The number of computer researchers was really small. They did amazing stuff. Like the Xerox PARC stuff, that's worth trillions of dollars now. It's added that much to the economy. And now as this wave of programmers just expanding, it's just growing, doubling every 5 years. That's what I've heard. I don't know if that's true. But it's growing in a fast rate. Everyone knows that. So fast, universities can't keep up. Boot camps are popping up because there's so many people who want to learn and are willing to pay a lot of money. Anyway, there are people who grew up in industry as part of this wave who are becoming aware that there was a time before microcomputing. And those people are starting new projects. They're doing the required background research. They're looking back into how we got where we are and what was going on before. I hope one day to count myself among them, but I can't really right now. I don't have the time to read all the stuff I need to read, but I am somewhat aware that that this is a problem. So I'm hopeful that the number of people who can work on this, who dedicate time to it, do computer research like it was done before the microcomputer revolution. I'm hopeful that something new is going to come out of it. It might take 20 years, might take 50 years, but the commercialization has just been so rapid and huge, right? It's just this huge wave. It's overtaken any of that prior research. So maybe it's even happening in the same scale. It just looks tiny and you can't see it compared to all of the, new versions of this software that comes out. And oh, look, a new OS version came out. And like, oh, look at this cool new hardware. And there's things like the end of Moore's Law and so the end of Moore's Law means that maybe Intel doesn't have the advantage that it once had. That it used to be that Intel would just keep working on making the same kind of processors, but with more transistors. same architecture. They advanced it, but the same architecture. And they knew it was flawed. They weren't happy with the architecture, but just because of the commercialization, this is what was selling. This is what was making money, so we're going to keep making them. They tried other things. They tried other chips, other architectures, but no, they weren't as successful, so they dropped them. But now, so they would just wait 6 months and the processor would be twice as fast. And any kind of custom architecture that was custom designed for a certain problem or a certain kind of language, or, these custom architectures that could use more clever things to make it go faster in certain cases. I mean, the Intel stuff would just double just by making the transistor smaller. And so any advantage you had with cool architectures was just, it didn't matter. But now at the end of Moore's Law, maybe that's mattering more and more. And we kind of see it with Apple. They're coming out with these custom chips, like for those AirPods. Maybe they have different architectures in there that allow them to be smaller, lower energy, etc. So that could be a thing. There's also like so much computing resources available. I feel like something could happen there. Like maybe we will realize that like we can start. I guess I want to say doing stuff that looks wasteful from the old paradigm, but in the new paradigm, it makes sense because there's like a vast cloud of computers waiting to run your code. I don't know about that, but I feel like there could be something there. There's the no-code movement that looks very hopeful to me, and I feel like I'm optimistic. The time frame I'm not optimistic about. I want it now. I don't want to wait 25 years. But, things have to take the time that they take. Awesome. So I hope I haven't bummed you out. I hope I ended on a positive enough note because I am hopeful. I just think that we took a huge down step to build out this industry, and we're only now realizing, collectively, how bad that back step was and how we still haven't caught up to where they were. But we are realizing it, and more people are realizing it, and there are conferences talking about it. There are conferences talking about the papers, and a lot of the papers that people bring up are old papers from a long time ago when this stuff was invented. So, yes, thank you. If you like this episode, you can go to lispcast.com/podcast, and there you'll find all the old episodes with audio, video, and text transcripts. You'll also find links to subscribe in whatever format you want, and also links to find me on social media, where I'd love to get into a discussion with you about this topic. This has been my thought on functional programming. My name is Eric Normand. Thank you for listening, and rock on.